Hello. Yes, we welcome you back to PSSB Physical Sciences Silver Bullet, and it's me, Richard, behind the channel. Okay, we are looking at this question today, and please don't forget to subscribe, and please don't forget to click that like button after subscription. Okay, the question comes: consider a system below where a charged sphere X, okay, this is our X, is suspended from a light inelastic string. The magnitude of the charges X and Y are given. Here they say comment on the sign of charges X and Y. Okay, when you look at this scenario, what do you see? We are having this charge, because on the string we would expect this charge to just fall under gravity, to be along this plane. But look at here, the charge stretches towards Y. What do you call that one? We call that one attraction. So X and Y are attracting each other. What does attraction has to do with the signs? Attraction occurs between charges which are oppositely charged, or which have opposite signs. And that's the answer. So what's the answer? The answer is that X and Y have opposite signs. Thank you. Let's have that one. Okay. Then 4.1 is supposed to be 4.2. It says draw a labeled free body diagram showing all forces acting on X. Okay. How do you go about that? Let us look at X. This is our X. What are the possible forces which are acting on it? We have one due to the attached string. Okay. And on assumption that it has mass, there is another force acting vertically downwards, which is Fg. So this is what we know. If this is it's a free body diagram, this is the force due to the string. Okay, this is the force due to its weight. So what do you call this one? Tension. What do you call this one? Fg. Then what else do we know? Now we know that X is being attracted towards Y. So there is an electrostatic force in this direction, which we will call Fe. And there we are. That is it, our free body diagram. Yeah, then comes another question. It says, calculate the magnitude of tension in the string. Okay. How do we go about that? So we already know the free body diagram. Let us look at it again. We have our tension. We have our Fg. We have our electrostatic force. Okay. Now you have to remember that we know this angle. this angle is 8 degrees. Okay, and if we have this plane, this one is also 8 degrees alternate. So how do you go about that? Then we can go ahead and find the components of our tension. Okay, we are going to have the vertical component and the horizontal component. So let us look at them. The vertical component will be this one, and the horizontal component will be this one. So if we redraw this is what we are going to get. We are going to get our electrostatic force this side. We are going to have our Fg downwards. We are going to have this component, and we are going to have this component upwards. But you have to remember that the component next to the angle is a cos. So you're going to have T cos theta. And this one is T sine theta. Now you need to know something, that this charge X is in equilibrium. What does that mean? It's not moving. If it's not moving, then we can apply that the sum of forces in one direction are equal to sum of forces in opposite direction. That's what equilibrium means in terms of forces. So we have two equations at place. One says T sine theta is equal to Fe. And another one says T cos theta is equal to Fg. Now you have to make a choice. Which one can be applied here? This one requires us to have the mass, and nothing was mentioned of the mass. So it's a dead end. That one leaves us with this one as our choice. As our choice of the equation. So this is what we have. Okay. And what does this say? It says that that T sine 8 degrees is equal to Fe, electrostatic force. And what is it? Is electrostatic force is equal to K Q1 Q2 over R squared. What does this mean? We know our K. Our K is 9 times 10 power 9. And our Q1, we have it here. It is 0.65 times 10 power micro minus 6, which is again 0.95 times 10 power minus 6. All of it over what? R squared, which is 25. Changing it to centimeters, you divide by 100, and it becomes what? 0.25 squared. That's what we have. So T sine 8 degrees gives you that. Okay, let's see what we get out of the Coulomb's law. So this is what we get. After reaching this, what do we say? We're going to have our T as 0.00 0.821 divided by sine 8 degrees, and what you get will be your tension. Let us get it. So that's what we get. We get our tension as 0.59 newtons. And with that, we would like to cut this video here. We thank you for your time. Don't forget to click the like button and also to spread the gospel of this channel. See you next time. This is Richard. The channel is PSSB, Physical Sciences Silver Bullet. See you next time. Bye-bye.